Hello everybody. This is our tutorial for how to graph the data that you've collected from your parachute drop experiment. You should have been given a half sheet of graph paper by the substitute. You are going to hold that paper so it's long, the long side is horizontal. Okay, we want the long side of the paper horizontal and the short side going vertically. I would love if you would use a ruler to draw your axes lines. All of our data is positive, right? You have positive area and positive amounts of time of drop. So we're only going to use quadrant 1 of our graph paper. And I know that you guys all know that, but I thought I would help out just in case. We're going to use a ruler and we're going to draw our axes lines. You do want to leave some space to the left of your y-axis so that you can put your labels. There, that's going to have to be good for me. So I'm going to draw this. I'm going to use up as much space as possible without eliminating my space for my labels. So leave 3 or 4 squares below, and then 3 or 4 squares to the left. Your data, we're going to compare our independent variable, which I am going to just jot down a couple notes here. Our independent variable, you should know from science class, is the one that we change, right? That's the one that we modified. So in this experiment, we changed the diameter of the parachute, but the part that we care about is the area of the parachute. Because as we increase the diameter, we increase the surface area. And we want to see how the surface area of a parachute affects the fall time of an object connected to that parachute. So our independent variable is the area of the parachute. And you should have that on your data table already. These values will be different for every group because some people used centimeters and some people used inches. So it is important that you label so that I am aware of what units you used. You can just put that unit over on the corner of the x-axis, so you can write inches squared or centimeters squared, whichever one corresponds to your work, and you should have that in your data table. So the x-axis is our independent variable, and that is the area of parachute. And then our y-axis is always our dependent variable, which in this case is the drop time of the parachute. So our dependent variable is going to be time in seconds. So you should have some number of seconds there. Now, your area may have come out to a big number. We're talking, if you're using centimeters, it might be in the hundreds, multiple hundreds. It really depends on what unit you use as how you're going to divide up your x-axis. You need to find the largest number and then round that up to a whole number. So let's say my largest number was 173 centimeters squared. I would take my highest value and say 175. Right, 173, let's round that up to 175 so it's a nice figure. And what I want to do is divide my x-axis into equal parts. This is the part that a lot of people have trouble with. So what I'm going to start doing is counting how many squares I have along my x-axis. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll put a mark there. 2, 3, 4, 5, 6, 7, 8, 9, put a mark there. Okay, so I have 47 squares that I can mark off. Let's say my highest area is set 175, right? I rounded it up. So I can do a little math and say 175 divided by the, let's say, 45 squares. And I can just stick that in my calculator and kind of get an estimate of how much each square will be worth. That's about 3.8. So let's say every box would be 4. That's what I'm trying to say. So every box would be 4. So it would be a 4, 8, 12, 16, 20. So this would be 20. And then 24, 28, 32, 36, 40, right? And then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That should be 60. That should be 80, 100, 120, 140, 160, and this one would be 180, right? So now I have an equal division of my x-axis. And again, yours is going to be different depending on what your numbers are, but that's how you can easily do it. Just a little bit of rounding. Your time should be much smaller numbers because you didn't drop that from very far. So again, you're going to find the highest time. Let's say it was 10 seconds. So I'm going to divide my y-axis up equally into 10 seconds, and I like this to be nice and spread out so my graph is not so tiny. So I'm just going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10 would be up here. Okay, I can extend that a little bit. All right, so you can make it more, you can make it less, but spread that out so it takes up the whole space. Now, what we're going to do is we're going to plot our data points. So you have a data table, and your data table should have 3 columns, but the last 2 should be area and time. And you're going to take these values and you're going to plot them as points. So if your area is 50 and your time is 3.5, then you would find where 50 is, 44, 48, somewhere in here. And you're going to go up to 3.5, 1, 2, 3.5. And it's going to be right about here. Okay, and I'm just going to put a point. Then I'm going to go to the next one, and I'm going to plot all 5, right? And so they could be anywhere, depending on how your data went and your parachutes worked. So you might have something that looks like this. And you can, if you would like, you can connect the dots. Do not go to the origin. Do not go to the origin. Start at the first dot and use your ruler and connect the dots. Okay, now it's not a straight line, and that's perfect. That's fine. Nothing ever comes out perfectly. But you can see how the trend looks, right? So you could see point 1 compared to the last point. What is the overall trend here? So what this graph shows us is the effect of surface area, that's F, on drop time of a parachute. And that is a great title for a graph because it tells us exactly what we're looking in here. It tells us what the independent variable is, what the dependent variable is. It shows us that we can look at this and see a trend, and we can draw conclusions from this graph and that title, and we know exactly what's going on. So once you make your graph, you're going to go into Brightspace. I think I have that open here. And you're going to go to Content. And we're in Unit 2, Design a Parachute. And number 7 is write a brief summary of your findings. How did your material work? What is the relationship between the area of a parachute and drop time? What forces are acting on a parachute? I want these in complete sentences so that you can formulate your thoughts and your summary. So please make those in nice, complete sentences. Make sure I can read them. You can answer them on the back of your graph. You could answer them on the same paper as your table, whatever you prefer. But please, when you finish, staple your graph to your data table. Everyone should have their own graph and their own data table. Staple those together, put your name on them, put your period, 1A or 4A, and then please give those to the sub to turn into my paper bin. When you finish, you should start reviewing for your quiz on the 3rd. Thursday, the 3rd, you will have a quiz on flight dynamics. I gave you a 1-page front and back guided notes. We filled those out a few days ago. I'd say around the 16th of February. You should have them in your notebook. If you don't, you can go to Unit 2's landing page, and there is a copy of the PowerPoint and the guided notes that you could go through and fill them out again. I want you to study and make sure that you do a good job. The quiz is not very complicated and it is definitely not very long, but I do want you to get a good grade. So please make sure you study for that. We'll take that quiz on Thursday, and then we'll jump into the next unit. So I will see you on Thursday. Good luck with your graphs, and we'll check in on Thursday as well and make sure everybody's all set. All right, you guys have a good one.